Hello, everybody. This is another Unit 3 video. We're going to talk about the vertex form of a quadratic function. We've talked about the standard form. We're going to talk about vertex form, and it should sound familiar because we saw it with the absolute value functions. Now, we're talking about quadratics, but they look very similar. Okay, so right here circled, you can see what it is for quadratics. For the absolute value functions that we've already worked with, the only difference was instead of the parentheses squared, it was just the absolute value bars. It works the exact same way. The vertex, because quadratics also have a vertex, is still found at HK. The axis of symmetry, then it follows, would just be x equals h. And then that a value isn't going to give us the slope because we're working with a curve now, but it will help determine the width, like how wide or narrow the parabola is, and the direction that it opens. We talked in the last video about how if a is positive, okay, it's going to open upward, and if it's negative, it's going to open downward. So vertex form is important because it helps us easily identify transformations, which we're going to talk about next, and it helps us find the vertex really quick. Probably why it's called vertex form. So let's look at transformations. Okay, and remember, we're comparing all of these functions to the parent function, which is just f of x equals x squared. Now, they work the exact same way as they did for absolute value functions. Okay, if I have a plus 9 after my x squared, that means that it's going up 9 units. It's a translation. If I have a minus 2, that means it's going down 2 units. Okay? If I have a negative, that's a horrible arrow, but you get the point. If I have a negative in front, that means that it is a reflection over the x-axis. And we have a plus 5 inside of the parentheses being squared. The plus 5 means that it's going left 5 units. And then lastly, we have a minus 4 inside, so that's going to actually mean that we're going right 4 units. And the minus 1 here means that we are going down 1 units. So there's a variety of transformations. Okay, these are some of them. They're pretty easy to recognize. And again, you saw this in Algebra 1, so this should all be just a nice refresher. What we're really going to talk about is how do we use the vertex form of a quadratic to help us graph? Well, kind of like we did with the absolute value functions. If I can find the vertex really easily, that's going to give me a nice starting point for my graph, and then I can pick some points around there and generate the rest of the graph, okay? So looking at the vertex form, if I want to find the vertex, remember we're looking at HK. Okay, remember that the vertex form is x minus h, so the h value in this example is actually a positive 2. Okay, so we have a positive h value of 2 and a k value of 3, so our vertex is at the point 2, 3. So here's how I'm going to use this information. First of all, I'm going to plot it, and then I'm going to put it in the center of my graph. Okay, x value of 2, y value of 3. The reason I'm doing that is because I still need more points. Okay, 1 point is clearly not enough to show that this is a parabola. So I'm going to pick points around this one by just going up and down with the x value. Okay, 2's in the middle, 3, 4, 5. And then above, I'll do 1, 0, and negative 1. Now, I know that this is kind of a bummer, but we have to plug those x values in to generate the y values so that we can actually plot the points. So let's do it. Okay, I plug in negative 1. Negative 1 minus 2 is negative 3. We square that and get 9, and then we add 3 to get 12. I plug in 0. 0 minus 2 is negative 2. We square that, we get 4. Add 3, we're at 7. Okay, I plug in 1. 1 minus 2 is negative 1. I square that. I get 1. I add 3, and now I have 4. Now here's a nice trick, okay? Because the vertex is on the axis of symmetry, and our graph is symmetrical over the axis of symmetry, I can flip these y values because of symmetry. So if I plug in 3, I should get 7. Oh, sorry, I'm looking at the wrong number. I should get 4. If I plug in 4, I should get 7. If I plug in 5, I should get 12. Now let's just test one to make sure we're not doing anything crazy here. Okay, I said if we plug in 3, we should get 4. So if I plug in 3 for x, 3 minus 2 is 1, squared is 1, plus 3 is 4. So it works. Okay, and you can check the rest of those if you would like. But I'm going to go ahead and plot the ones that I can. Now, I'm not going to be able to plot all of these points because some of them will be off of my coordinate plane here, but I'm going to get all the ones that fit. So let's see, we can do 1, 4. We can do 0, 7. And that's going to be it. So this is the left side of our parabola. And then the right side. So what I was talking about the symmetry is, we know that this is our axis of symmetry right here. So we know that the left side of the parabola is symmetrical. So we could just flip it over or do a reflection over that axis of symmetry, and it's going to give us the points that we found in our table. So use that symmetry to your advantage, please. All right, and that's all there is to it. Okay, we will talk later on how we can use our calculators to generate these tables for us, but for now, it's just a good refresher on just how to plug in numbers and evaluate functions. So I hope the video was helpful. Please let me know if you have any questions, and have a great day.